So let's look at a problem that has a little bit more complicated arrangement of units. So nitroglycerin used to treat patients with angina is prescribed for a patient by IV at a rate of 225 micrograms per minute. The IV bag contains 50 milligrams of nitroglycerin per 250 milliliters of D5W, which is a dextrose solution. How many milliliters per hour should the patient receive? So that's the entire problem. We're going to go back and read through the problem and pull out the information that we need to solve the problem. So the first part of it says nitroglycerin used to treat patients with angina is prescribed for a patient by IV. That really doesn't give me anything about information about that I'm going to need to solve this problem. It does tell me that the rate, the dosing, is 225 micrograms of the medication per minute. And then it tells us that the IV bag, contains 50 milligrams of medication in 250 milliliters of solution. And it's asking for how many milliliters per hour should the patient receive. And so I can go over here and write milliliters per hour equals question mark. So that's just kind of remind me what I'm actually looking for. Now what I'm going to do is look at all the units that are kind of involved and see what other relationships that I might need to solve this problem. So these three pieces of information were what was given in the problem. Now I see I have micrograms in one place and milligrams in another. It's a pretty safe assumption that I'm going to need a relationship between those two things. And it may be that you write down some relationships that you don't end up using, and that's perfectly fine. It's better to have them and not need them than need them and not have them. So I've got my milligrams and micrograms. I see I've got a time in minutes and I've got a time in hours. So probably going to need to know 60 minutes in 1 hour. And then I've got milliliters here and milliliters my answer, so that is looking okay. So what I'm going to do when I go to solve this problem is I'm actually going to go to the end and I'm going to write down what I'm actually looking for, what units I want. I know I need milliliters per hour. Now I'm not too worried about numbers right now because I'm just worried about the units. And so what I can look at is I say, well, based on the two pieces of given information, so I was given this relationship and this relationship, and the two conversion factors that I know. The places that I see time are in this conversion factor and in this rate of dosage. Now, I'm usually not going to start a problem with a conversion factor like 60 minutes in an hour. So that gives me a clue that I know that I can start the problem with this setup, and it doesn't really matter which one I start with. The reason I start with this one is because of the minutes. That's a time, and I've got a time on the bottom. No matter what, when I put this relationship into my calculation, it has to be with the minutes on the bottom. So I start with 225 micrograms per minute. And I see, okay, I have minutes on the bottom. I know in my answer I need hours. And it doesn't really matter which unit I look at to convert first. All I'm really worried about doing is making sure my units work out correctly. And because I know minutes is going to hours, I'm going to do that first. So what I look at is I have 60 minutes per hour, and I put minutes on the top because I want those units to cancel out. Now, if I stop the problem at this point, I would have micrograms per hour, and that's not what I want. I do want the hour, so that's great, but not the micrograms. So now I need to get to milliliters. And I see that I have another relationship here that relates a mass to a volume. And what I have here is a mass and a volume. So this looks like a really good candidate to use. The only problem is that I have milligrams here and micrograms there. So I'm actually going to convert my micrograms to milligrams. And in this case, I put the micrograms on the bottom because what I want to happen is for the micrograms to cancel with the micrograms, and I want to be left with milligrams. So I can flip those conversion factors however I need to make the units work out correctly. Now I have milligrams on top and hours on the bottom, so I still don't have my milliliters. That's the next thing I need to do. And what I can look at is now this relationship that relates the milliliters and the mass, and I'm going to put the 50 milligrams on the bottom because I want that to cancel out with the milligrams that are in the numerator. Again, I'm setting this entire problem up based on looking at the units. And the way I started it, the one I knew to start with was the time one, because I knew time had to be on the bottom in my final answer. So I'm going to start with a relationship that has time on the bottom. Because for this problem, we don't have like a number that's all by itself, so sometimes it can be a little bit hard to figure out where to start that problem. Now I see that I've got everything canceled out. Now I can do my calculation. So I have 225 times 60 times 250 divided by 1,000, and then that answer divided by 50. And I get an answer of 68 milliliters per hour, because I can only keep 2 sig figs, because what I see is that my 50 there, 50, it has the decimal place after it, that has 2 sig figs, so my answer must also have 2 sig figs. So this problem's a little bit harder to figure out because we have all these things, kind of conversion factors and relationships, and we don't have that one number that only has one unit associated with it, so we need to make sure that we set the problem up correctly.